This is a video solution for problem number 4 from the February 1982 Junior Competition on Probability. In order to complete a flight safely, a 4-engine airplane must have at least 2 of its engines working properly for the entire flight. If the probability of an engine running properly for the entire flight is 0.92, what is the probability that the plane will complete its flight safely? Okay, so the probability of one engine working is 0.92. We are told in order for the plane to complete the flight safely, at least 2 of the engines must be working properly. So if I completed my flight safely, that means 2 engines were working, 3 were working, and 4 were working. Okay, I'm going to calculate the complement of that instead. So I'm going to take 1, and I'm going to subtract the probability that none of the engines were working properly. And then I'm also going to subtract the probability that 1 was working properly. If I take 1 and I subtract 0 and 1, that's going to leave me with 2, 3, or 4 engines working properly. Okay, so the probability of none of the engines working is 0.08 to the 4th. So the probability of the engine working is 0.92. So the probability that it doesn't work then is 0.08. And I raise that to the 4th power because we know that our airplane has 4 engines. Now the probability that one plane is working, or one engine is working, that engine working, the probability is going to be 0.92. Then I still have 3 that are not working, which is 0.08 to the 3rd. Last thing I need to do is remember to multiply this by 4. If I have a 4-engine plane, there are 4 options for the engine that could be working. Now, when I simplify all of this, I get 0.9981.